step of this is to be solving equations. So what I want to do here is just real fast review with you guys how you find the angle. So what is the angle? You see something like this, it's asking you again, what is the angle that has a sine value of root 3 over 2? Well, when you do that, when you have them written like this, you start out with, well, sine between here and here. It's positive, so it's first quadrant. Sine is opposite, so that's root 3, and that's my 2, so that's my 60 degrees. So what I'm looking at, though, into today, into 14.4, which we'll work on between today and Friday, make sure your answers are just plain old boring radians. Tomorrow when you do this, you'll give me radians and degrees because that's what I'll ask for. What's the radian value of 60?
Pi over 3.
Good. So it's pi over 3. Tangent negative 1. When we're working with tangent values, again, we're just trying to find what is the what is the angle that has a tangent value of negative 1.
45.
In order for it to be that, it's got to be 45. Since it's negative, it went down to the fourth quadrant. So it's negative 1 for opposite. My adjacent to 1. So it's negative 45 degrees. When we solve this one, we're looking for tangent, or our theta values were always going to be between pi over 2, negative pi over 2, excluding them. So our answer here would have been negative 45 or negative pi over 4. Bless you. Nothing different from what we've been working on those little worksheets, stuff that I gave you over the past few days. What's going to change, though, is today I'm going to ask you guys to find the angle that solves an equation. And when we do that, there's going to be more than one angle. For example, if I'm looking at just this, where is the other angle that has a tangent value of negative 1? Isn't there two of them?
Yeah. Is it in the second quadrant?
Up in the second quadrant, and what's that angle?
135.
135, or 3 pi over 4. So what we're going to do is we're going to ask this question slightly different. And this is section 14.4. I'm not going to start with that. We're going to ask this we're going to find all the angles that solve that equation within one revolution. So you're going to find all the angles that solve this equation between 0 and 2 pi.
This is part of 44 procedure.
This is part of 14.4, yes. We're pulling these problems out of 14.4. There's two sets of styles of problems within 14.4. We're going to work on what I think is the easier of the two. Good. And it basically mirrors everything we did in 13.4 by finding angles. It's just we're bouncing them around the circle as opposed to just within those singular quadrant for the singular angle. Hi. It's sunny out. I'm sorry. In this case here, what we have is 2 times the sine value of some angle minus 1 is 0. If I wanted to solve for x, what would you do? Add 1 and divide by 2. Good. What I want you guys to start thinking of is this sine of x. If you want to treat that as the variable itself, just treat it as 4 letters. Okay, for right now. Not that 4-letter word. Thank you. Bad joke. 4-letter word, not that 4-letter word.
No, I got the joke, but I just thought that saying sinks was
Stuff.
funnier.
Stuff is 5, but math is hard. Anyway,
Never change that stuff.
yeah.
Double stuff, like Oreos.
Yeah, like
They don't spell it.
Oreos has 4 letters.
To get x by itself, you would say this then. your value of x, your angle, is going to be what angle has the inverse sine of 1/2. Remember, those two statements were equivalent. Sine of theta equals a half, or sine inverse of 1/2. What is the angle that has a sine of a half? So what we do, we plot, it's positive, 1/2, so it's 30. What is that in terms of radians?
Pi over 6.
Good. So this is pi over 6, but now you have to remember, I know I'm asking a lot here, what other quadrant is sine positive?
Third.
Which is it?
The negative one, which I thought was.
Well, you say third.
No, it's the second.
The one
One,
negative, it's the negative
two,
one.
3, 4.
It's the negative one.
Second.
Second quadrant, sine is positive. So if I have a reference angle here of 30, it's still 1 and 2. But what is that theta value? What is it? 150, but otherwise known as
4 pi over 6.
5 pi over 6. Okay? What you're looking at here, guys, is that you have to remember that in your quadrants, cosine is positive, sine is positive, because x is positive, y is positive. Here it's negative, positive, negative, negative, and positive, negative. Bless you. Tangent is positive in the third, and tangent is positive in the first. Because tangent is sine o, which is y over x, thank you. Tangent's y over x, so it's sine over cosine. Here tangent's negative. So you're starting the problem like you would normally by figuring out what quadrant it's placed itself into with your negative values and all that. And then you're just asking what other quadrant, what other angle does it work in? Does that make sense? So sometimes you'll get 2 answers, sometimes you'll get 1, sometimes you'll get 4. It all depends on the problem.
How would you only one answer if does not everyone have a recipe?
Think of like cosine of x is 1.
Are you going to have new ones within half a revolution where the second angle would be outside of that, therefore there'd be 1 answer?
No, what we're looking at here is it's going to be within 1 revolution. We're looking at within 1 revolution, and then on Friday we're going to talk about what's called a general solution. And we'll talk more about that later. We're just looking at within 1 revolution, what are the angles that have a sine value to a half? Pi over 6, 5 pi over 6.
Are the ones with 4 inches, are they going to be like sine x squared?
Yep.
Do we ever have to like memorize stuff like that? Like we have to memorize sine of negative 1/2? Or we just have to be able to figure it out quickly?
Figure it out. Because there's no reason to memorize the unit circle. As long as you know your right triangles, you're fine. You're done. That's all it's based off of. Okay? Let's see. 4 times the cosine of x plus 1 equals negative 1. What are you going to do first?
Subtract 1.
And then divide by 4? So we're at cosine of x
Negative 1
equals negative 1/2. Good. Be all right with that? Like I said, a lot of these you probably be able to get the start of the problem done in your head. So that means what is the angle measure? What is the angle that has a cosine value of a negative half?
So it's gotta be in the second quadrant.
Got to be in the second quadrant. And remember, when you're dealing with second quadrant cosine problems, you have an adjacent and a hypotenuse. Your adjacent is the negative 1. Your hypotenuse is your 2. Your root 3. So this is a 60 degree. Now that's a 60 degree reference angle. What is the theta value?
Pi over 3.
120.
Oh, we're saying.
Yeah, but you're right, it's pi over 3. The reference is pi over 3. So now, if it's at 120 degrees, but I want radian value only, it is 2 pi over 3. What other quadrant is cosine negative? Right below it, so you have to bounce your reference angle down another pi over 3, and you're at 4 pi over 3. Now you give me scratchy face, what's wrong?
So you find a reference angle and then you try to like the total angle.
Yes, cosine's the weird one. Cosine's the weird one a lot of times when you're bounced to the second quadrant. Remember, your reference angle is always acute. But when you're in the second quadrant, you're looking for the obtuse angle coming over. All right? Same thing if your reference angle, your reference angles are always going to want to be in first or second quadrant because you can bounce them down below. You're always going to have anything between 0 to 360 if you want to think of it that way. So it's possible to have a 220 degree angle if you had to, or 7 pi or something. It's fine. It's okay, but this goes back to placing reference angles to the second quadrant, using that bounce up, but the whole is what's coming over.
So, cosine is the angle, the obtuse angle of the triangle.
When you build it out like this, yeah. But I mean, there's subtleties between the types of problem. When you see an equation, it's fair game. If you just see cosine inverse -1/2, you're bouncing it to that single quadrant and just writing out the 1/8. That's where it just gets to be a little difference.
Mr. Murphy, does the reason we have two answers stem back to how you made like that weird looking graph thing? Is how like you have quartics and they have multiple answers and stuff?
That's exactly what's happening.
Just making sure.
That's exactly why this happens.
Square cosine?
No. No. 5 over 3.
That's gonna be.
You get the tangent of x.
Oh, okay.
You don't have to go that far, Zach. Watch.
Should graph it.
By not going that far, I know that I'm looking for an angle. What angle has a tangent value of 1 over √3? Now, could you write it as √3/3?
Yeah.
You can, but then you still have to unrationalize it to figure out what your opposites and stuff are. Because tangent is opposite over adjacent. So if I'm looking at it, in this case, since I'm solving my equation, knowing that my tangent value is positive, I'm going first quadrant, my opposite is the 1, my adjacent is the √3. What's my angle? 30. Okay? That's the reason why I don't need to worry about rationalizing, because it doesn't matter. Does that make sense, Zach?
Yeah.
So I know that I have a 30-degree reference, so what's the radian?
5/6.
Okay? Where else is tangent positive? Third quadrant. So down here, I move it down to pi over 6, and I'm at
5 pi.
7 pi.
7 pi.
7 pi.
There's 4, that's why they're called quadrants.
This is the same guy who thought the word stuff had 4 letters, so.
Having an off day.
That sounded like less
What's that?
That sounded like less.
There's something.
So basically, where else is the answer positive?
Yeah.
And where else is the answer negative?
Yeah. It's really all that we're looking at here. See how it's just subtly different than just starting here?
Is it gonna get bad? It's gonna get bad.
That's just syntax. It looks like it's a syntax.
Can you just remove the sign?
Why?
Because they're.
Algebraically, how do you do it? Well, wait, no. Wait, let me write it down first. We'll come back to that. You have sine of x times the tangent square of x.
Wait.
Because they're multiplication too.
Oh,
Yes, ma'am.
would you divide by the sine of x, and then there'd be sine over x over sine over x, and that's 1? And then
Yes, ma'am. What's happening here is, notice that it says sine of x times tangent squared x equals sine of x. And the easy way to get rid of a sine is just divide it. You divide both sides by it. That's just using algebra. Sine over sine is 1. So now you have the tangent squared of x is 1. How do you undo squaring?
Square
Square
root
root
it.
it.
And that's because
Square root
tan
it.
x is one whole thing. It doesn't.
Correct.
Okay.
Now, the square root of tangent squared of x is going to be tangent. What's the square root of 1?
Plus or minus.
Plus or minus.
This is coming back. No.
The reason you have to go plus minus in this
Equal
case is
sign.
because you took this square root over both sides. Okay? So now, this is asking you what angle or angles has a tangent value of plus or minus 1.
This how you get four
Does
answers.
it be in all quadrants?
It does.
It's on,
It's in one and the other.
45
both
degrees
sides.
on
It's-
first and on
it's-
third.
Angles.
We know it's a 40, we all know it's 45 degrees, right?
Yeah.
What's the radian?
Pi over 4.
So first quadrant's pi over 4. What other quadrant is the positive?
5 pi over 4.
5 pi over 4. So all I do is move to the third quadrant.
Big bow tie.
Okay? What is the value in the third quadrant, or second quadrant?
3 pi over 4.
And then in the fourth quadrant? So this equation has 4 possible solutions.
There can't be any more, can there?
Oh yeah.
There can?
Yeah. What'll happen eventually, when we get into these a little bit more, is that we're going to be doing some factoring with this. And you could wind up, I think the most I've seen, no, I think I've had one before that had like 6 or 8 possibles. Because you get plus or minuses on one. I think you get about 6 of them sometimes.
Will we ever get like imaginary?
No. Nope, nope, nope.
What do you do these?
Because does imaginary wind up between 0 and 2 pi?
Imaginary.
You can think about it, but it's not there.
So to clarify, when you do these equations, you only want the answer radians?
Yes, please. And Zach, I have no problem with you build, because we're always going to build our triangles and go in there, and we normally, even I build them with, I say 45, but then automatically we'll write pi over 4, or I'll write, pi over 6, and then just start moving stuff around. And that's fine. This is not a problem at all, okay? But for these, when you're solving equations, your results, because the parameter that I'm giving you is between 0 to 2 pi, implies that it wants radian. If it said 0 to 360, just give me anything. But I won't be that nice. Want to try one?
Sure.
Mr. Murphy, you should try it.
I will. I put it on our website.
Did you?
I did.
I didn't see that.
Wait, what
I made the post.
There's some colors.
Math. Did you try factor?
It will give them hope.
I'm going to do factoring ones. We'll do that stuff on Friday.
Okay.
I'm going to give you guys stuff a little bit cleaner today. I apologize that there's a line there, that it's not 0.3.
That's it.
So cool.
Is that,
Should make that line a little bit thicker, but whatever.
is that why easy?
Yes, pretty much.
Pull white out.
I only have
Now is the time to
Whatever.
both sides, which is more slightly more.
Take a minute. I'll start on the first one if you finished up the other one. So,
I'm finishing the first one.
So yeah, secant squared of x is 4/3. Now, there's one of two ways you can go about doing this. If you're not comfortable working with the inverse, just invert both sides of the equation. You still get an equivalent fraction. So, or you can just work with secants, because secant would be hypotenuse over adjacent. It's not a big deal. I'm going to flip it, because I tend to work with just cosines and sines. There's no reason. So then that would be cosine squared is plus or minus, oops, 3/4.
Oh, I didn't see that. Oh, I thought the 3 was the number. Oh,
Thank you, ma'am. All right. Now I take my square root. Okay.
I thought the 3 was a part.
It is.
I thought the 3 was the number of the product.
No,
That's
3
why-
secant
that's what
squared.
I thought too.
That's why.
That's why I whited out that value so you can see it.
I thought it was like a line in my book or something. I don't know.
I'm positive it's supposed to be there.
What happened?
Anyway, take your square root. well, we don't have plus minus yet. So take our square root, so our cosine value of x will be plus or minus root 3 over 2. So what angle has a cosine of plus or minus root 3 over 2?
Virus. You said
Root 3 to cosine 30, so it's pi over 6. It's going to wind up being in all 4 quadrants because it's a plus minus, because you're going to have 2 positive values and 2 negative values. So if pi over 6 is your reference angle, all you have to do is bounce that into each of the other 3 quadrants. You get 5 pi over 6, 7 pi over 6, and 11 pi over 6. Is there a reason or any rationale between what order you put those in when you list them out? Does it make any difference whatsoever? No. Makes no difference, guys. It really doesn't. If you want to list the positives first and then list the negatives, that's cool. Not a big deal. Okay? But are you starting to see why inverse functions work? Because you can do these things. And like Clay was asking here a second ago, is that as we get to our ideas of graphing these, when we start to graph these, as you go around the entire circle, cosine at 0 is 1. You won't get a calculator for it, so you won't bother looking at it. Cosine at pi over 2 is 0. Cosine at pi is negative 1. Cosine at 3 pi over 2 is 0, and it's back up to here. So what's happening is 3 pi over 2 is occurring somewhere around here, and here for positives, here, oh sorry, here. Yes, I have a sheet.
That looks like a
Here, here, negative, and negative. So you have your 2 positive values and your 2 negative values because they follow the curve.
I didn't realize.
And that's why this happens. Okay?
I didn't realize they would change it back to cosine.
Oh, you didn't have to. If you left it as secant, you would still get this. When you would happen here is if you'd have secant squared was 4 over 3. So the secant of x would have been plus or minus 2 over the square root of 3. So that's still saying it's the hypotenuse over adjacent, and you're still at a 30-degree angle. It works just the same.
Yeah, I messed myself up and went sine.
Oh, you flipped it. I gotcha. I gotcha. All right. Yeah, that's really the only trick, Zach. When you're flipping back, make sure you understand that secant goes with cosine, cosecant goes with sine. But that's, for right now, that's really about as complex as I really want to go with a lot of these things. Yes, ma'am. This, no, but it's the next progression of the step, and why sit here and do nothing for another day? We got stuff to do. We could have, but we didn't.
We should have watched
The other problem.
We've already watched enough Brad. We watched the dance scene, we watched the wedding scene, we watched the starting scene. It's enough.
Wait, Mr. Murphy?
Yes.
Okay, so we're getting everyone. I thought you were just like.
No, I'm not forgetting the other one. On this one, it's not 0.5, it's 5 times the cosine. What I want you to think of when you see 5 times the cosine minus root 3 equals 3 times the cosine, think of this as 5x minus root 3 equals 3x.
Oh, then
What do you do?
You subtract.
Subtract. You pick up the little guy. Subtract the 3 cosine x, add the root 3, and you get 2 cosine x is root 3. Does that make sense? That's the little trick. Bless you. Because you haven't dealt with this before, once you see it once, you're like, oh, well, that's easy. So what angle has the cosine value of root 3 over 2? Did we just do that? It was 30 degrees. So your answer is at pi over 6 and 11. It's at pi over 6 and 11 pi over 6 because those are the 2 quadrants that cosine is.
Positive.
I took the 3x, 3 cosine x from the right side, and I subtracted over, and I added the root 3. See it now? If you treat it the same idea as you would of 5x minus root 3 equals 3x, move that, move that, move that.
What was the point it was throwing out?
Yeah.
Action there, it was like.
Excuse me. I'm sorry, it's just not a very clean picture. There's another crazy one I want to get real quick.
Wait, what were you under? Oh, wait, you said, when you said factoring, you mean like cosine squared and then like cosine and no cosine?
What'll happen is we'll have to factor out common terms. Like here. This is 2x to the 4th minus x squared minus 15. You have to factor.
I was wondering if it was like, you mean like we put the numbers on this side and.
There's other ones like that as well. We'll get to it. We'll get to that. We're not doing that today. No, not today. So let me give you a few of these for tonight. This is 14.4. I want you to do, what page was that again? I forgot. No, it's not a 6. 860, you're close. I put these up online. It's section 14.4. I put another tab on the webpage, so that these are already there. What I want you to do will be 34 to 42. So, but skip 36 and 37. So no 36 or 37. And I crossed out that first one. The first one there, that 5 cosine minus 3, you wind up with what angle has a cosine of 3/5? Well, you got to press buttons on your calculator. We're doing that. Everything we're going to do is going to be built off of a circle. 36 is the same idea. You get a funky decimal. 37 is a factoring problem. We're not there yet. We'll worry about that later. I just want to give you guys the idea of what is the angle and continue working like we have been. Okay? Tomorrow we'll re-quiz and we'll go over this stuff on Friday. So if you don't bother with this and just study for your quiz tomorrow, that's cool.
So this is what?
This equation will not be on there. It will be just like your other quiz. Everybody's going to re-quiz, and I'll make the decision if you tank it on purpose or you actually tried, as far as which grade you get.
You mean a pop quiz?
No, you can't just say because I said so.
I don't know which one's which. Both have little things in the back.
Wait, but
Okay.
it's like the same time as that?
Yeah, it'll mirror that. It'll just be different problems.
You should make it the same.
No, I've done that before. You'd be surprised at how poorly people do it.
I would fail.
It's kind of funny because like it's the same question. It's like we had a test question not too long ago that was a homework problem.
I remember that. And then there was one on the quiz that you reviewed that in class.
Right.
And then I got that right. It was about multiplying and switching fractions.
Yeah,
around. I remember that.
What if I try and get a couple of
What's that?
What if I try and get a couple of
Well, then I'll figure that.